Hi everybody and welcome to today's Lego Technic video. What I'm doing today is a second tutorial on the Powered Up app. So of course this is the app that allows you to control your Powered Up hubs, like this one over here, and that in turn controls a Powered Up motor or motors. And in the previous tutorial I pretty much went through how to create a project, how to do some of the basic coding blocks and things like that. And what I'm going to be doing today is assume that you've already done some coding, or if you watched my previous tutorial. And in that tutorial I did cover a lot of coding around setting motor position, so you can set the angle of your motor. And today I'm going to focus more on the speed of your motor, controlling motor speed. So if that's something you're interested in, please keep watching. Alright, just tell you a little bit about the setup that I've got. So I've just used a regular Powered Up hub, and what I've done, I've pulled out the battery pack, and that allows me to connect with these alligator clips straight onto a variable power supply. Now the reason I've done that is just simply so I can simulate the impact of a varying voltage on the motor speed. So of course as your batteries do drain, you will find that the voltage that they produce does reduce. And that does mean your motor speed will drop as well, and that's important to take into account in your programming, that if constant speed is important to you, that is something you need to be aware of, that over time, with your battery draining, you will get a different output speed from what you think you might get. The other important thing for me has been the type of tablet I've used. So I've used here a Samsung tablet. And the main difference for me has been just the screen size. So in the beginning, when I first started using Powered Up, I used the phone, and I did find that the screen space was fairly limited and it was quite hard to do the programming. So I do recommend a large screen tablet for coding programming, just to make it easier to be able to see your whole program easily and be able to manipulate the code blocks. Alright, so let's get straight into it. I'm going to push the coding button that creates a new project, pretty much a blank screen. First I'm going to make sure that my hub is connected to via the Bluetooth connection, and it is. So if it isn't, you're going to make sure you push that green button and get it connected. I'm going to bring up the motor control icons, and like I said in this introduction, I'm going to focus on speed control. The speed control icons are the ones with that kind of a loopy arrow around the axle. So that's this one here. This one there, that's for speed measurement, and these are also other speed controllers, and these are all for single motors. There are some for controlling dual motors and things like that, but today I'll just focus on single motor control. If you're not seeing all these icons, there is an option on the menu that allows you to choose how many icons you are seeing. So it's kind of got a beginner mode, intermediate, and advanced. So I just like to have it on advanced so I can see everything that's available. Alright, so we'll start talking about the first speed control icon. It's the very first one on the left, so we can drag and drop that on here. And this is a power control option, or controller. And what this does is turns on the motor on this particular port. So again, you've got your 4 ports on your hub, A, B, C, and D. In this case, I'm using port A, and it's going to set it to a particular power percentage or voltage percentage. In this case 50%, and I can vary that, and for example make it 100%. So by having this, what that means is that once this runs, it'll turn the motor on at 100% power. Now in order to make that work, of course, I do need some sort of user interface around that. So what I'll do is create a button to make that work. I'll just add a button, that's button 0, and go back to my controller. What I'll do, I'll have a conditional start, and it will start once I push button number 0. So what this whole program does, the program will start once I push button 0, and it'll turn the motor on to 100% power. So I'll just demonstrate that. There's our button, very simple. Push it, and look at that, the motor goes to 100%, and that is the maximum speed. And like I said earlier on, I've got the voltage control over here, so as I do reduce the voltage, you can hear the motor speed reducing. So generally speaking, there's a linear relationship between the voltage and the speed, and so if I half the voltage, I'll half the speed. It's very much linear, and that, like I said, is important for your programming. Alright, so just turning on your motor with a single button is not that interesting, so what I'm going to show you now is how to vary the speed of your motor using one of the slider control widgets. So if you do go to your UI interface creator, there are all these slider widgets, and what they do, they allow you to change the speed of the motor, so the output of that widget as you move that center up and down is simply a value between 0 and 100, and you can input that into your motor controller and change the speed depending on that slider. So we just need to do the code blocks to control that. So what we need to start with is your motor power settings. So we'll just simply drag and drop that motor power. The input to that will be that slider widget. So that slider is set to widget number 1. So what this does, it inputs whatever the output of that slider is into the speed of the motor. And of course what we need to do is do that continuously. If you just program it like this, it will be a one-off. So what I need is a control loop around that. So I grab this control loop, put that around the entire code block, put a start on it so it always starts, and that will then allow us to control the speed of the motor with that slider control. So again, what this program does, it always starts, it goes around in a loop. Within that loop, what it does is it reads the value of the slider control and feeds that into the speed of the motor A. So I'll just demonstrate that. So I can go and run that program, go to the control screen, and by varying the slider, I can set the speed of the motor. So you can see going between 0 and 100, so that's maximum speed, and we can also go negative and go backwards. So that is one way of varying the speed of your motor just through the UI. You can dynamically set that motor speed. Okay, so we can now control the speed of the motor with either with a slider or just simply with a button that sets it to a particular power level. Now, of course, like I said, that will set the speed of the motor, but the speed of the motor will actually vary not only with the voltage but also with the loading on it. So if we do have some loading on the motor, it will change its speed. And for some applications, it's really important to know the actual speed of the motor. So there is a widget for that. Under the again, the motor controllers, we have got this control icon there, and what that does, it allows us to measure the speed of a particular motor, so in this case motor A, and the output will be put onto here. And of course that output needs to be put onto some sort of display. So we can go to our UI, we can add another widget. Now there's these special output dial widgets that are quite useful to use. So for example, this blue one, I can add that on there. And what that will do, we can feed a value into that and display that value on the dial, and kind of move the dial across as well to give a readout of the value that we're measuring. So in this case, we're going to measure the speed of the motor. And if we go back to our programming, we can use this special UI widget and feed into that the motor speed. So what this block does, it takes an input from the dial, takes that value from the motor and displays it on the dial. And of course you've got to set the UI value, in this case it's number 2, and we need to do this continuously with a loop. So we just put a loop around that, and we need a permanent start button. So what this code block does, it will always start, go into a loop, it will measure the motor speed and display it on dial number 2 on the interface. So I'll just demonstrate that. So at the moment we've got the dial showing 0 because the motor is at 0 speed, but as we apply power to the motor, we can see that speed being measured and displayed on that dial. So as we vary that speed, we can see we're getting a value between pretty much between 0 and 125. Now I have noticed, of course, like I said before with the voltage, as I do increase the voltage, for example, I set it to 100 and increase the voltage, we can see that value increasing. But it seems to have a maximum of 125. In fact, sometimes it goes negative, it goes loses the plot a bit at a high voltage. Now, of course, normally you've never had such a high voltage, but it is interesting to see that there is a limit that they have set within that value. 125 is pretty much the maximum, or mine's 125. Now, I'm not quite sure why that is. It would make sense to go above that if the speed actually is above that. Another question I've always had is what are the units of this speed, because I do know that the maximum speed of a powered up motor, for example, is around 320 RPM, and the RPM doesn't seem to correspond to this value here. Perhaps it's a percentage of maximum, but then again, why would it go to 125% if the normal speed of, you can't go above 100% obviously unless you change the voltage. So what I'm going to demonstrate next is how to measure the speed in RPM using some programming code blocks. Alright, so we can now display the motor speed on this dial here using the internal motor speed measurement, but like I said before, the issue with this particular measurement, it's not clear what the units are. So what I'm going to do is write my own speed measurement loop. I'm going to show you how to do that. I'm not saying that will be a better value, it's just going to give us a different value in terms of revolutions per minute, which is what I'm used to. So in order to do that, we're just going to add another widget. So in this case, we use another dial. We're going to put that dial on the user interface as well. We're going to go back to the programming. And what we're going to need is some sort of loop to do the measurement. So we're going to grab a loop, where that loop is always going to start. And then what we're going to do, in order to measure the speed, what I'm going to do is going to measure the current angle of the motor. And then 1 second later, or a period later, I'm going to re-measure that angle. Then of course the speed is simply that difference in angle divided by the time period, and I'm going to make it quite simple. I'm going to use a time period of 1, so that way it makes it easier just to divide. You don't need to do that division by 1, and that's going to give us the number of degrees per second. Now in order to convert that to revolutions per minute, we need to divide that value by 6. So let's start with the angle measurement. Now what I need to do is measure that angle and then 1 second later measure it again. So I need to store that value for later, and the way to do that is to use variables. So variables, you can think of variables as little boxes where you can store values for later use. So for example, I can use this variable here, this box, and what that will do, that will allow me to store a value into this box, and that box is going to be called box A, or lowercase a in this case. So what I'm doing here is taking the measurement of motor A, the angle, and storing it in variable A. What I'm going to do then is wait 1 second. So that's a 1 second delay. And then I need to display on the output on that dial the difference between the new value of A and the old value, and divide that by 6. So in order to divide that by 6, actually first I've got to set that UI element to 3. The special mathematical operators, which I haven't just showed you yet, but these are on here, and they allow you to do either logic or mathematical, and what I need is division. So I'm going to divide a value that I'm going to get from that difference by 6 in order to convert the units, and that difference is going to be subtracting 2 values. Wrong side. And the 2 values I'm going to subtract is the new measurement of the motor angle. So I need to go to the motor angle of motor A and subtract the old value stored in this box. So I need to go to the variable boxes, and I need to grab this box here, box A. So that completes the program. So what this is doing, we're going to start, we're going to measure the current angle of the motor A, we're going to store that in variable A, going to wait 1 second, and then we're going to measure the new value of A, so that'll be a higher value, subtract the old value stored in that box A, divide the whole lot by 6 and display it on the dial, and then repeat. So that is our program for measuring speed ourselves. Alright, so let's see how well it worked. Let's go back to the interface. So now we've got our 2 dials. So this is the internal speed measurement, this is our own speed measurement in revolutions per minute. We're going to start up the motor and see what happens. So here we go. Now, of course, the internal speed measurement is updating a lot more quickly. What we're doing is only sampling every second. So you can kind of see it change every second. And the values are fairly consistent, but not 100% consistent. They do kind of vary a little bit with that sampling. You can make this a faster sampling period simply by changing that loop. Instead of having a 1 second delay, you might have a half second or even a tenth of a second, and adjust the unit conversion accordingly. So instead of dividing by 6, you might only divide by 3 or less than that in order to convert that. But as you can see, it's definitely working. We're getting our own measurement. And this is in revolutions per minute. So if we do go to the maximum speed, as we know, the revolutions per minute of a large powered up functions motor is around that 360, and again it can vary per voltage. But as we can see already, this is already at the maximum, so if I do have to drop that down a bit to around 100, then you can see we're sitting around 250. Now in terms of the conversion between the internal speed and RPM, I've just kind of noticed it's about 2.5. So you need to multiply the internal speed by 2.5 to get the revolutions per minute. So I'm not saying you have to use this particular method to sample your speeds, but what I am saying is if you do want to convert to revolutions per minute, you simply have to multiply that value by about 2.5. Not saying 2.5 is exact. I haven't done a long-term measurement, but that's just looking at the numbers at the moment. It seems to be fairly accurate. The other thing, of course, is that as we change the voltage, we can see, of course, the speed's going upwards, like we talked about before. And this measurement here will max out at 125, will become inaccurate, whereas this measurement will keep its accuracy regardless of the voltage that we set. Alright, so I'm just showing you how to create your own speed measurement algorithm or loop that will translate between the internal speed measurement and an RPM value. It's about 2.5. What I want to show you now is another speed widget or control element. So I've demonstrated the first one, which is just setting the power or the voltage of the motor, but that speed that you end up getting will vary with the load on the motor as well as the voltage being applied. There is another widget here or tool which in fact sets the speed of the motor. Now, not only does it set the speed, but it also has got this little arrow there that they've all got. What it will try to do is maintain that speed regardless of the voltage or the load being put on the motor. So it's got an internal, I guess, control mechanism within the powered up hub, and that will try to keep that speed at whatever value you set it at. So what I'll do, so at the moment I've got my control loop here that reacts to that dial. So rather than setting the power, what I'm going to do, I'm going to use it to set the speed. I need to replace it because otherwise they will be in conflict, so I won't need that one anymore. So that's the power setting. We're now using the speed setting. So if we go to our user interface, so this is now rather than power, it's speed. So if I, for example, set this to a certain value, so for example it's set to around 50, what that means is the powered up hub will try to keep that motor going at that speed of 50 regardless of the loading. So if I do put some loading on it, so what I've actually got here is a loading mechanism that I can activate that will then put quite a bit of torque on the motor. And as you can see, it is now being controlled and sped up in order to maintain, or more power is being applied in order to maintain the average speed of 50. So you can now, if you look at the amps being used, it's now quite high, whereas without the loading it was a lot lower. So I just repeat that, I've got to take that off. So just like this on 50, we can see the amperage is about 0.07 of an amp. Put that loading on, we're using a lot more power as it's doing a lot more work. Oops, clicking a bit there, but you can see that the speed is being maintained. Same if I actually change the voltage. As I change that voltage upwards, you can see it's actually not increasing the speed. If I put the voltage downwards, it will keep adjusting the power to the motor to maintain that consistent speed of 50 units, which of course when translated to RPM is around that 130. Interestingly enough, this measurement is a lot more steady now than this one over here. Now the maximum value that you can apply to that speed control is actually only 100, even though the actual speed can go to 125. And the reason for that is just simply to have some, I guess, power in reserve in order to adjust the power level on the motor to be able to maintain that speed. So if I do set this to 100, for example, it will maintain a speed of 100. However, as soon as I put on some loading, it will really increase the power being applied to the motor. And if there's not enough power available with a lot of loading, you can see it can't actually maintain a value of 100. It's just simply not enough power available. If I do increase the power, then obviously it can get to that value because I've applied more voltage. There is a limit to, of course, the speed control. If the amount of loading on the motor is too great, then it's not possible to maintain that high speed. But obviously for lower speeds it is maintained, and that allows you to create maybe a car or a vehicle that under load will maintain the same speed. So driving up a hill, the motor power will be increased to maintain a constant speed, which could be useful in some applications. Alright, so that was the speed control element, very useful for keeping your motor at a constant speed. It's I think it's a very clever control element. One other one that's actually very similar to that one, so we've now covered the power control, the speed control, and this one over here is another version essentially of that. Speed control, it's got that same speed control management there, but the difference here is it's also got a timer element. So what you can do with this particular element is say, okay, I want motor A to be kept at speed 50 for a time of 5 seconds. Now, to me, this element's kind of a little bit redundant, because you can simply produce the same thing by using the other element and then having a timer and stopping it after 5 seconds. So it's just really just a shortcut element to achieve the same thing. So you know, there are a lot of elements that do have some redundancy within them, and this is a good example of that. You've got that extra timer. I can't really think of an application where you'd use that over another way of doing it, but obviously, you know, it just makes it easier to do some of the programming. Okay, so that's been a summary of some of the speed control elements available for powered up hub motors. So we've got power control, we've got speed control, we've got speed measurement, and we've got speed control given a certain amount of time. That is my summary of some of these elements. I hope you got something out of it. Please like and subscribe, and thanks for watching, and we'll see you next time. Bye.